Let's look at an example of arithmetic sequences. Example would be 20, 24, 28, 32, and 36. The recursive formula for a sequence such as this would be an equals an minus 1 plus d. And d stands for the common difference between all the numbers. So the difference in that previous sequence would be 4, because 20 plus 4 equals 24, and 24 plus 4 equals 28, and so on. However, the recursive formula can be a little difficult because if you wanted to find a term such as the 50th term in that sequence, you would have to know the previous 49 terms to figure out the 50th term. So there's a more explicit sequence such as an equals a1 plus d times n minus 1. And the an stands for the term you want to find. So if you wanted to find the 50th term, you would just plug that in, and it has no actual value. And then a1 would be the first term in the sequence, so it would be 20. And then d is the common difference, so that was 4. And then n is just treated like a variable in the sequence, so if you wanted to find the 12th term, you would just plug in 12 for n, so it would take on that value. So going back to the previous sequence, your equation for the explicit formula would be an equals 20, which was the first term of the sequence, plus n minus 1 times 4, which was the common difference. And then you would just simply simplify. So then you would get an equals 20 plus 4n minus 4. And then break it down even more, you'd get an equals 4n plus 16. So if we wanted to find the 50th term, you would simply plug in chug all the numbers. So the 50th term, a50, equals 200 plus 16. And we got 200 by taking the common difference, 4, times the term we wanted to find, 50. And then plus 16, you would get 216. Now you can see it was easier to work with the explicit formula rather than the recursive formula to find a particular term in a sequence.